Hi everyone. So we will be covering on vector analysis and vector calculus. But before we do that, I thought it would be very nice if we refresh about some basic ideas on vectors. So let's go. So the first thing we need to recall is the magnitude of a vector. So in the case where you have a vector A, which is written like this, you have a vector A which is represented by an arrow on top, and this is written as AXI plus AYJ in the 2D plane. So the I and J with the head here represents the unit vector in a positive X direction and the positive Y direction. Okay, and AX and AY is basically the components in the X and Y direction respectively. So the magnitude of the vector A in this case is just the square root of AX squared plus AY squared, right? This equation. So what happens if you have a 3D? The answer is very simple. You have three components, so you have AX squared plus AY squared plus AZ squared, right? Then we come to this commutativity. So let's say we have a vector A in this direction here, and then we have a vector B. So you go from one point here, following A plus B, so you end up at this point. So this is my A plus B vector. Alright, so in order to go from this point to this point, you don't have to necessarily use this pathway, but you can also use a third option, which is by going B first. Recall that this vector B and this is the same, right? This is the same vector B, and here you go B first, and then you go A, right? So therefore, A plus B is equals to B plus A, right? Now the next one is associativity. Here you have three vectors. Uh, if you look at the left hand side here, you see that there is a parenthesis. So basically we have to solve this first. So you have A plus B. So basically if you look at the vector A, this is your A, vector A plus B, right? So you reach this point. So then the vectors A plus B is this one, this line. So now you go A plus B first, and then you go to plus C. So you end up at this point, right? So A plus B first, and then plus C. So now on the right hand side, you have A first. So A first is this point, this line, and this line. After that, you will go with B plus C. So B plus C is this line, B plus C. Okay. So it means you can either go A plus B first and then plus C, or you can take A first and then you go with the line of B plus C. Right, so in both cases, this is also going to give you the same point if you follow the pathway of A plus B plus C. So this straight line here. Alright, so basically this is associativity. So now let's go to the multiplication of vectors. There are two kinds of multiplications. We have scalar product and the vector product. So a scalar product is also known as a dot product. And here we look at the example of a scalar product. If you have these two vectors, you have A, vector A represented by the orange line here, and vector B in the green line. So when you take A dot B is basically equals to the magnitude of vector A times the magnitude of vector B times cos theta, right? So basically what you are doing essentially is taking the vector B and you project it on the vector A. So when you take the vector B projecting on vector A, you will have this value, the component of B along A, right? So this is also going to give you the same value if you take B dot A. So B dot A, basically what you're doing is you are going to take vector A and you project them onto the vector B, right? So A dot B is equals to B dot A. So another way to write the scalar product is to take A dot B to be equals to, you write it in terms of the components. So here you write AXI plus AYJ for vector A, and then let's say the vector B is going to be written as BXI plus BYJ. So here, when you take the dot product, the unit vector, if they are along the same direction, then they are going to be orthonormal. So I dot I is going to be equals to 1. So here, therefore, you have ax times bx, this term, the first term here. But then you don't have ax by because I dot j is going to be equals to 0. They are orthogonal, which means the theta is going to be 90 degrees. So cos 90 is going to be 0. Then you have ay dot bx. Here this is equals to 0 as well because j dot I. And you only have the next term, which is ay multiplied by by because j dot j is equals to 1. Right, so this is the dot product of the vector a and b. So the next one is the multiplication of vectors, the vector or cross product. So a cross product is defined like this, a cross b. So here in this case, your direction is important. So normally we take the, let's say a cross b, you have a vector a, and then you cross to the vector b. So the resulting vector is going to be pointing up. So like this example. So you have vector a cross b. So if you use the right hand rule, your vector c, which is the resultant of a cross b, is going to be pointing upwards. So the definition a cross b is equals to magnitude of a multiplied by magnitude of b times sine theta. So here, if theta is going to be equal to 0, you'll see that this is not going to give you any vectors because sine 0 is going to be 0. So here, and you have 90 degrees, then you have this nice orthogonal vectors. Right, so I give an example here. You have, for example, a vector a equals to 2i, means this is along the x direction, positive x direction. And then you have a vector b, which is equals to 4j. So this is along the y direction only. So when you take the cross product, you are going to get 8k, right? So I kind of write this in terms of determinants. So one way or easier way, if I could say, to evaluate a cross b is by writing it like this. So first you write ijk at the first row, and then you write the components of the vector a, in this case ax, ay, az, and then the next row is your component for vector b. So in order to find the resulting vector of the cross product, basically you just have to solve the determinants. So you can prove to yourself that if you do this method, you can also get 8k here. So I gave one more example to show the cross product, just to give an idea, right? So in this case, let's say we have vector a, which is 112, and vector b, which is 210. So here you notice that I use a different notation. Instead of writing ijk, I write it in terms of coordinates. So this is 112 basically is going to be 1i plus 1j plus 2k, right? So this is this vector, and 210 is going to be 2i plus 1j plus 0k is going to be this vector. So when you take the cross product, you have this z direction. So similarly, this is another example. You can try to work it out and check whether the answer is correct. Right, so basically these are the important points that I want to share with you on the basics of vectors. And next one, we are going to go into the equation of straight line. So see you next time.